2018 from Systronics. Okay, it's a single beam spectrophotometer. Okay, we have a two source lamps here. Okay, first one is UV lamp, the second one is visible lamp. Okay, the wavelength of this instrument is from 200 to 1000 nanometer. Okay, so UV ranges comes from 200 to 340 nanometer, and 340 and above is it's a visible range. Okay, and here we have a knobs like transmission, absorbance and concentration modes. This one is concentration knob to set concentration. Okay, this one is set 0. Again, this is low, medium and high sensitivity ranges. Okay, this one is setting for 100. Okay, and one more thing, here we have 4 compartments. Okay, and here we have filters like say for example, if I wanted to use 360 nanometers, then we need to go for 340 to 380 nanometer the filters. Okay, and if I want to go for more than below 340 means I need to select this filter. Okay, again we have dark filters in the intermediate. Okay, if it is above 580 nanometer means I need to go for above 580 nanometer filter. Okay,
the meantime we have to shift.
Yes, yes. So if I am using, let's say for example, I will go with 420 nanometers. Okay, I have selected. Okay, and meanwhile if I am using visible range, then I need to turn this knob to visible range. If I am using UV range, then I need to turn this knob to UV range. Okay, so if I am trying to using around visible range but I am keeping this visible only means it will not work. Okay, then I need to go for UV itself if I am using UV. Okay, now I have selected 420 nanometer. Okay, before that, once I select the 420 nanometer, I need to go for dark filter. Okay, to make the instrument 0. Okay, so this should be in transmission mode. Okay, just I kept dark filter, this will be in transmission mode. I am going to set it for 0 by using set 0 knob. Okay, once I set 0, then I need to take distilled water or any reference solution with respect to standard. Okay, so now I take distilled water. Okay, I'll keep into the compartment. While keeping the cuvette, the shaded part should be opposite to you. Okay, the transparent part should be light passing way. Okay, so just I'm keeping. Okay, and I need to select the filters as per my wavelength. So that is 380 to 580 filter. Why? Because I have selected 420 nanometer. Again, here also the same thing. I need to start from very low sensitivity, but need to keep this at the end. Okay, at the end position. Okay, if it is crossing 100, then I need to reduce the value and to make 100. Okay, once I set 100, then I need to go for absorbance. So most of the cases, so we will find out only the OD values, and thereafter according to our OD values we will plot the graph with absorbance and the versus concentration. Okay, so this is the procedure. Once it is showing 0, then I need to keep the actual sample. And the solution should be 60% of the cuvette. Okay, so you are not supposed to fill entire cuvette, that means 100% of the cuvette. Okay, that may spill out the compartment. Just now you read the absorbance value. that is 0.069 is your absorbance value. Okay.
We don't know. This is the higher absorbance. We have to shift the wavelength again. We have to check. No?
Say for example, now I have set it for 420 nanometer.
Particular wavelength absorption.
Yes.
Right now. We don't know whether this sample will absorb the light at this
At this particular moment or not. If you want to go like that, means you shift the wavelength here, like, see the observance will change it. Okay, this is the way you need to find out. Okay, you can decrease as well. Usually dichromate is having around 420 nanometer. In that nanometer, no, it comes very good result. For that I have kept 420 nanometer itself. Okay, so like this you need to go. Okay, so this is the absorbance. So just I'll decrease the concentration of this one. I'll check. Okay, it is reducing. Okay, so likewise you need to find out the OD value or the absorbance value. Then after you need to go for the graph. Okay, and one more thing, this concentration. See, concentration, we need to prepare some different standard solutions like 2 ppm, 4 ppm, 6, 8, 10 ppm, like that. Okay, the maximum concentration we need to take, and we need to set the maximum concentration like 10 ppm if I am having 10 by using set concentration now. Okay, then you need to cross check like 8, 6, 4 and 2 are coming respectively or not. So like as we did for the flame photometer. Okay, so there we were setting the intensity. So here we need to set the concentration, actual concentration of the standard solution. That's it. Okay, and one more thing, so once you switch on the instrument, you need to wait for 10 minutes for the warm up of the instrument to get stabilization of the source lamp. Okay, so after 10 minutes you can use the instrument. Okay,
So when we are using visible range,
that is what. See, if I am using only visible range, then you can switch it off the UV range. Okay, it is not necessary. So if you are using UV range, then you can switch off the visible lamp. Okay, so there is no need that the both lamps should be in on condition every time. So it depends on the wavelength whichever, please.
there is no problem. It will select only depending on this now.
Yes. Okay. Okay. So if I'm using more than 340, I need to switch on only visible lamp. If I'm using less than 340, I need to go for UV lamp. Okay.